All right, good night, everybody. Today we're looking at, and I'll be sharing my screen, my entire screen. So today we are looking at calculating the number of elements in two subsets. And we said that when dealing with calculating the number of elements in two subsets, that there were three equations that we had to keep in mind. The first one was the number in universal set is equal to the number in A union B plus the number in A union B all complement. We spoke about that. Two, we said that the number in A union B is equal to the number in A plus the number in B minus the number in A intercept B. And thirdly, the number in A intercept B complement is equal to the number in A minus the number in A intercept B. And today, we're going to be looking at how these are used to solve these kinds of problems. All right, so let's look at what we have today. So I've chosen two distinct types of problems for us to look at. The first one is this one. It says, in the Venn diagram above, the number in A is 17, the number in B is 18, and the number in A intercept B is 5. Find A, the number in A intercept B complement, and B, the number in B intercept A complement. Now, if we look at the formulas, it is obvious that it is the third formula that we're talking about. Because if you notice, A says number in A intercept B complement, and that's exactly how the third formula starts. So that is what we are going to be doing. So let's go down. So to solve this problem, we say we have to start given, and we write out the information of that section. So it says the number in A is 17, the number in B is 18, and the number in A intercept B is 5. So 1, we're looking for A only. That is what is meant when we say the number in A intercept B complement. It means A only. And that is equal to the number in A minus the number in A intercept B from the third formula, Mr. Africa. I say to make your face. So that comes from this formula. We were asked for it. We were asked to find the only, and this is the formula that corresponds to that. So one of the first things we need to do is learn the formula. If we don't learn the formula, this is gonna continuously be a problem there. All right? So we continue. The number of A intercept B complement, which we call A only, is equal to, what's the number in A? If you notice this line, the number in A is 17. So I put 17 minus the number in A intercept B is 5. So I put the 5 there. So I have to continue from there. So I say the number open bracket of A intercept B complement, or what we call A only, is equal to, well, 17 minus 5. 17 minus 5 is 12. And we're talking about elements. Notice this is only half the question. The next question says the number of B intercept A complement. That there, we call it B only. So how we're gonna do to the formula is we're gonna put the B where the A is, and we're gonna put the A where the B is. So B only is gonna be the number of B intercept A complement is equal to the number in B minus the number in A intercept B. In other words, let's look at it in the diagram. If this whole thing, this circle that you see I'm going around in, is 18, contains 18 marbles, of which 5 have already been placed aside, how many marbles are left in this region that I am moving the cursor in? Anybody?
13, you say 18 or 17?
18 for that section, darling. So it would
Sorry,
be 13. Exactly. So let us write that out in set notation. So we'll see, we already have our formula. We already wrote our formula. So B only, which is the number in B intercept A complement, is equal to the whole circle. The whole circle, B is 18, as I mentioned, minus the middle part is 5. So 18 minus 5, as you said, is 13. So there are 13 elements in there.